Hello, today we are going to take a look at this DC to DC converter from Victron Energy. It's called Orion, model number is 2412 and it's mean a 24 volt input and 12 volt at the output with the maximum current of 25 amp. Example use case for that unit is when you've got two lead acid batteries that've got a 24 volt combined, but you would like to connect appliance that is running from a 12 volt. So this device is going to grab our 24 volt and step down it to 12 volt. This is a non-isolated model. Currently I've got a linear voltage regulator with a heatsink that looks like this. And when I'm pulling a 150 watt from it, it is hot as hell. It is dissipating a 50% of the power as heat, and it's warming up space, and it's absolutely terrible and inefficient. When this model is a switch mode, and because of that it's got a high efficiency. Here you've got the sample use case, the model number. As you can see, the input voltage can be from 18 volt to 32, so you've got absolutely no problem in using a different chemistry than lead acid. And the output is 12 volt, 25 amp, but the output voltage can be adjusted, so it can output like a 13.8 volt if you've got appliance that require that. I'm 99% sure that this device is not going to be working, and that's because I purchased it from a 1/5 of the price from someone who is selling like a customer returns from Amazon or Conrad Electronics, and I'm pretty sure that it's not working. The seller said that it is fully operational and it was tested, but he mostly sell like home stuff, like clothes, and I'm pretty sure they do not have a technician to try it, and they just say, okay, it is fully operational. If you've got problem, then you can just return. Default voltage is 13.2 volt, which I believe is absolutely great. You could even use this for a recharge different battery. It is non-isolated, so it's going to have a common ground. You've got also a remote on-off switch, and that's going to be part of my solar system. So let's take a look at the device itself. This is how it presents. So we've got a 25 amp of continuous load and 35 amp of maximum load. So it is even overrated. The Victron Energy is a very good company, and it is a quite expensive unit if you compare it to a generic cheap Chinese stuff. Here is our terminal block. We've got the input from 18 to 32 volt. We've got a common ground, and the output 10 to 15 volt. And here you can adjust it. There is a small port. And here is a remote switch, so you can remove that link. We've got a switch in your dashboard if you would like to put that in a camper, and you can remotely control it. And as you can see, design in Netherlands, made in India. One question for you: could you recognize that label from which shop it was returned? That would be quite interesting. Is it Amazon or is it a Conrad Electronics? Both of those companies are carrying a Victron Energy products, and I'm pretty sure someone recognized the label. So let's try to plug it in. So here is our positive input, our common ground, which goes to the negative. Let's go 20 something volts. Let's try to power it on. And let's do the measurement. on the output we should get around 13 volts. So let's see what's going on. And we've got absolutely 0, which can be expected. Let's take a look, do we have any inrush current? It absolutely do not react, so it needs fixing. Let's do that. Let's take a look what we've got inside. As I told you, here we've got a heatsink, massive heatsink. We've got a lot of MOSFETs. We've got big chunky inductor with a beefy wire that looks like a 2.5 millimeter solid core, or maybe even bigger. We've got tons of capacitors, a lot of capacitors, the pot for adjusting, and we've got 2 car fuses. Let's start from them. Let's remove them. Let me take a look how do they present. The fuse is definitely burned, but this doesn't mean that we've got a success, and that's because if the MOSFETs are shorted, then the fuse is going to be blown out, because the user manual does not say anything about user replacing them. That one is also shorted. This is a 15 amp fuse. I've got a small mindfuck, and that's because those fuses have a 15 amp rating, so we've got a total of 30 amp input, but the output is 35 amp, but of course it is not linear, so we can pull a much more output current from less amp at the input. We are cutting that in half because we are using half voltage, so definitely a 30 amp is a great value, even overrated. I found my beautiful Chinese set of fuses, and we've got exactly a 15 amp as we would like. I'm going to put just one fuse, not to blow all I've got, but I will use a regulated power supply, so even in case of short we should be okay. That go beautiful. Let's try to power it on. So we've got our main input, our common ground. We've got a spark that scared me a little bit. Let's see the output voltage, and we read 0, but that's because I do not have the on-off link. Let me put that. That was my mistake. And let's try to hook it up right now. And looks like it's working. We've got a 15.6 volt, which is a little bit too high. I hope the regulator is not broken. Let's try to load it with my lamp. And they're absolutely beautiful, just take a look. Just take a look at this, my 12 volt lamp. It's nice and shiny. We've got absolutely beautiful work. Let me measure the output voltage under load. We definitely need to lower down the voltage. Let me grab something. Let me nicely try to lower it down. And we are lowering it, as you can see. We are testing it under load. I would go around a 13.2 volt. Let's go to the factory one. And we've got a we've got a working device. So as you can see, the current is very low, and that's because we are stepping down our high voltage and we're basically cutting it in half. Only half input is required to power our device, and it's working absolutely beautiful. Let me put our second fuse and turn everything together. Okay, 2 fuses are safely seated inside. Here goes. Let's take a look what I found. We can nicely slide it off. Here is a bonus picture of what we've got inside. So it is absolutely beautiful. This is a good amount of switching MOSFETs, good amount of filtering, and a beefy inductor. Looks absolutely beautiful. I'm pretty sure that someone reversed a polarity. That is my assumption, because you need to have a small technical skills. That was top, if I recall, and we can try to put it back like it was. We've got absolutely beautiful purchase. That was definitely worth. I put our converter back. As you can see, it looks like straight from the factory. I love the blue look of the Victron Energy. We've got our 2 broken fuses. Let me do a last check to make sure that we are good to go. We've got 2 fuses. That one didn't make me scary because I was prepared. Let's put the common ground and our output, and we've got our beautiful voltage like we assume. Then I'm going to hook up our lamp. Here is my DC lamp to those 2 wires. This is absolutely not correct way to do it, by the way, but this is just a small test, and it is a low current device. I've got everything up and running. Let's do a last check. Let's measure how much power the converter is drawing right now. We've got almost 1 amp, exactly 1 amp. We can vouch for that. I'm going to measure you the voltage, 24 volts, exactly 24 volts, as you can see, very beautiful. And let's measure the current at the output. We go to the DC, we zero that, and here is wire to our lamp. Let me clamp just onto the 1 wire, and we've got 1.71 amp. So if you want, you can calculate the efficiency. Here is the output voltage, but that's just only if you would be interested. I'm not interested in that. I'm very happy that we've got make it working, and I'm very happy. From technical point of view, I could write to the seller that he sold me a not working thing instead of a working one, but as I told you, I pay 1/5 of the price for it, so I assume that it's going to be broken. So I'm absolutely happy. 2 fuses. We've got a good device for my solar system. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.